the century, the Dandenong countryside was a placid place where life moved at a leisurely gait. The quickening tempo of our crowded days was not yet apparent. In a good-natured democracy, there was always time for a passing word on the road. And if a stationary cart occupied the road, it didn't matter. Nor did it matter if goods took longer to reach their destination. It was the day of the horse, and transport was geared to the tempo of that useful animal. Everything moved at a leisurely gait. Half a century later, Dandenong was still a pleasant place, but a busy one. The horses were gone. In their place came the transport vehicles. And among them today, you will see a preponderance of trucks which identify themselves by this monogram. Thus it is with pride that International Harvester tells the story of its truck and its making. A truck that is serving Australian haulage needs in some 60 different models. That is where they are made, in the Dandenong plant of International Harvester. Located 20 miles from Melbourne on 57 acres of land, it is pleasantly situated in an area which provides healthy living for its army of workers. The plant comprises 3 major sections: engineering, cab production, and main manufacturing buildings, as well as an administrative block and cafeteria. Opened in 1952, it has developed into one of the most orderly manufacturing plants in the Commonwealth. The story starts with the departure of a shipment of Australian pig iron from Whyalla in South Australia, and its arrival at International Harvester Geelong Works. There, in the hands of a workforce of highly competent men, the manufacture of the truck begins. Australian pig iron, Australian limestone, coke, and a percentage of steel and iron are the major raw materials of the first process. A traveling magnetic crane handles the pig iron from the bins. Before the first charge of the day is deposited in the melting furnace, called a cupola, the bed of the cupola has been filled with coke to a set height. The charge consists of quantities of iron, pig iron, and steel, carefully measured by weighing and dropped into a charging bucket. On top of this material is placed a layer of coke with limestone and a small quantity of ferrometals to maintain the specified analysis. Now the bucket goes to feed the fires of the cupola and produce the liquid metal. And so the Australian raw materials become molten iron, ready for use in the foundry, which is the birthplace of the International Engine Block. The foundry is centered on a continuous traveling loop, which is the foundry's major production line. Cleanliness and scrupulous attention to the avoidance of litter contribute to efficiency and morale. At the beginning of the molding and pouring sequence, the molders prepare a sand replica of one side of the engine block. This sand has been specially prepared to make the well-finished precision castings required for these parts. As one half of the mold is hoisted, the pattern for the casting is revealed. Here is seen the impression of the pattern left in the black sand. is now inverted and placed on the production line. The sand surface is sprayed with a special preparation and then set alight so as to dry the surface. At this stage, the mold is ready to receive the cores, 3 per engine, which form the space within the engine block. The cores are made nearby. The technique used in making the core differs slightly from that used in the engine block mold. Sand is packed into the boxes and tamped down to form a solid mass. When the box is removed, the core is revealed as a solid representation in sand of space inside the engine block. The core is then subjected to high temperatures in a baking oven. Many other cores are made in this section of the foundry, and here we see the forming of a cylinder head core. Now, one of the engine cores is immersed in a prepared solution. This solution ensures the casting will have a smoother or better finished surface before it is taken to the production line to be placed in position within the mold. Beside the production line, the cores are set into position, ready to become the center of the mold. The cores are lowered into position by a special positioning fixture. The space between the molding sand and the cores represents the wall thickness of the final casting. The completed mold is now approaching position to receive the molten metal, which will become an engine block. At the control panel, temperature, pressure, velocity, and volume of air in the cupola are automatically recorded. From the cupola, molten metal is continuously flowing into the receiver, which is called a forehearth, and from there the glowing stream is poured into a ladle. As the stream is flowing, a metallurgist with a special pyrometer makes a visual examination of the metal to check its temperature. The ladle of molten metal moves off on a traveling hoist to fill the molds that are moving along the conveyor loop of the production line. The metal is poured into the mold and fills every available space between the core and molding sand, becoming, in effect, the engine block of an international motor truck engine manufactured in Australia. Back at the cupola, a small amount of metal is cast for metallurgical tests because the specifications of the metal are rigidly controlled and recorded. The metal solidifies to become a casting as the mold travels at a predetermined speed through the cooling tunnel. On emerging at the other end of the tunnel, the top of the mold is removed, and the casting is lifted off the line and placed on a pallet, while the empty frame is returned to the beginning of the conveyor loop to take its place again in this endless cycle. The engine block is followed by a cylinder head, and other castings such as manifolds, flywheel housings and gearboxes are made in this foundry. Now the cooled castings are taken for cleaning. First they pass over a vibrator to shake out the casting sand which still remains clinging to the casting. Next they are placed in a wheelabrator, an ingenious machine which takes a load of castings and subjects them to severe shot blasting with fine shot under high air pressure. This results in a clean metal surface. Because it is obviously important that the water jacket surrounding the cylinders should be perfectly watertight, each engine block is tested under water pressure. Finished castings are spray painted with a priming coat against a water curtain which carries away the overspray. When they pass out of this section, the castings are ready for the many machine processes which follow. These commence with the milling of the faces at the front and rear ends of the engine block. Among the many modern intricate machines used in manufacturing international trucks, there are none more impressive than the vertical and double horizontal multiple spindle drilling machines which drill all holes required in a series of automatic operations. But of equal interest is the honing machine, which hones the cylinder bore. The fluid used in the process is refrigerated so as to absorb and control heat generated by friction. This permits extraordinary accuracy. After the machine cycle is completed, the bore diameter is measured by an air gauging instrument, which has an accuracy of 1/10,000th of an inch, equal to 1/20th the diameter of a human hair. This air gauge indicating instrument is located beside the honing machine, and indicators moving up and down on the scale reveal the close tolerances of the bore. This machine is profile milling the contours and depth of the 6 combustion chambers of the cylinder head. Of course, there are other components of the vehicle to be processed. Here, for example, a component is being butt welded. Here, a gear shifter fork is being drop forged. This bar automatic lathe is a remarkable machine. When it is set up to make a particular part, it continues the production of the part without further attention until the steel bar stock needs replacing. Here it is making a valve spring retainer, one of which is completed every 14 seconds. But to return to our engine block, it has been cast, water tested, prime painted, completely machined and given a protective grease coating. It has also been given its final inspection as a single unit and is ready for the many engine components to be assembled into it to become a complete international truck engine. And so the first stage at Geelong Works is concluded by the departure of the various castings and finished machine components to the motor truck works at Dandenong. Situated at the junction of the Princes and South Gippsland highways, the Dandenong Works is in an ideal industrial location. The first assembly stage is reached inside the works at the point where the chassis rails are delivered by this crane. Riveters commence the work of construction by fastening the frame cross members. Cold riveting is employed, and the rivets are forced by tremendous pressure up to a 25-ton squeeze, thus filling every section of the holding cross member and chassis rail to make a tight fit. This method is more efficient than is hot riveting. Spring hangers are also fitted to the chassis rails at this point. The milling of spring hangers is done on this Cincinnati milling machine. In fitting springs to the now formed chassis, a rawhide hammer is used so that the shackle pins are not burred in the process. Now the front axle is needed, and the forging of the front axle is an example of the contribution made by many other Australian manufacturers, each specializing in its own particular field. Such components are made to harvesters' blueprints and specifications, and the same standards of quality control are followed as in harvesters' own works. Alongside the assembly line, the rear axle is prepared in a sub-assembly bay as the chassis moves on its way. The brake assembly is placed in position and riveted. The brake drum and hub assembly takes its place on the rear axle, and finally, the live axle shaft is inserted. The whole assembly conveys an early impression of the ruggedness of the truck to come. Now the completed rear axle is assembled on the chassis. Meantime, in an adjoining bay, operatives make petrol tanks using a specialized method of electric seam welding. As all the work so far has been carried out with the chassis in an inverted position, it must be turned over before it is placed on the assembly line. As it is brought across from the chassis assembly line, the cradle which carries it enables the turnover to be made easily and rapidly. The chassis is hoisted onto the main assembly line. At its next station, its engine will be added. And here we return to our castings. Before they take their place on the engine line, the castings are cleaned to remove the grease coating which has protected them against corrosion whilst they were in transit from Geelong Works. Though a fundamental job, it has to be thoroughly done and is planned to be done speedily, cleanly and easily. The engine block is lifted onto dollies on the engine assembly line. The clutch housing is aligned with main bearing tunnels and dowelled into position. Here we show another operation at Dandenong, the machining of the flywheel, which is made ready for assembly into the engine. As the engine passed along the line, the camshaft had been put in position, and now the crankshaft is lowered into its place. The pistons follow as the rapidly evolving engine reaches the next station on the assembly line. And the cylinder head, complete with its valves, valve springs and rocker arms, is added. It has been a short journey in distance and time from the original casting to a completed engine as it is turned over and moves along the line ready for testing. On the engine test line, each engine starts on its own starting motor, is adjusted, and its running is checked in every detail. After testing, it is spray painted and becomes the Husky Black Diamond International engine. Meantime, the gearbox is prepared. The gears, manufactured in New South Wales, are fitted into the housing which was cast and machined at the Geelong Works, Victoria, to form a complete all-Australian gearbox. All gearboxes are tested under load in all gear ratios. Electronic test instruments are used for this purpose. When the gearbox has been fitted to the clutch housing and engine, the complete unit is then ready for the main assembly line. And here it is, at the engine drop station, where it is lowered into position to be dropped into the chassis. After the engine is in position, the partly completed truck moves into a painting booth. Here, the chassis is spray painted and moves on. It is completely power lubricated. Now it needs a cab. Close to the main assembly line is the cab production section, where cab sections are first located in a jig. The metal panels are held in the jig and welded together. In another section, doors are made in an assembly fixture. The inner and outer shells are placed in a jig and pressed together. The edge of the outer shell is turned over and flattened by a pneumatic peening hammer, thus assuring absolute rigidity of the door. At the last stage of the cab assembly line, metal finishing and buffing is done with portable grinding tools. Then the cabs and other sheet metal units are placed on a conveyor line which first takes them into a 5-stage cleaning and phosphating process, assuring a clean, rust-inhibited surface for paint application. They continue onto the painting line, operated on the same moving production line principle: prime paint booth, then drying oven, again paint booth, and final drying oven at a temperature of 300 degrees Fahrenheit. The total distance traveled by the cab is 640 feet. Spray painting is carried out in specially designed booths by methods which result in a brilliant hard-wearing baked enamel finish. After painting, the cab emerges from a final drying tunnel ready for the assembly line. First, however, the windscreen assembly is put in position. The precision manufacture of every component is seen in the fact that the windscreen is fixed in position quickly and easily. The method of sealing it is ingenious. Now for the name, which identifies it as the finest truck on the road. The front sheet metal is added. When this is done, all wiring is completed, so that when the cab is assembled onto the frame, it becomes relatively simple to make the final necessary electrical connections. Back on the main assembly line, the truck, complete with engine, has reached the cab drop station. The operatives bolt the cab to the chassis and complete the electrical wiring. The truck is now complete, but before it leaves the line, the headlights are tested and focused, and fuel is added to the tank. Now the finished vehicle passes on to test rollers which rotate with its driving wheels as it undergoes a simulated road test. Every gear ratio, also the clutch, brake and instruments are tested and checked. When the truck is driven off the line, it is a top-grade product made possible by the use of the best of material and the highest possible standards of workmanship. Here, wheel alignment is checked by an automatic indicator. And so international trucks are made. 60 different types and sizes, a vehicle to fit every job. '60 models. That engine has a tremendous work capacity, and that capacity springs from a number of factors. The human factor is vastly important. In the background of all efficient manufacturing organizations are the men who make the product. Any product is as good only as the skill of its workmen can make it, and this is true of the International. In the foundry, the forge, the machine shop, in the paint booths, on the assembly lines, and in the office, the workers carry out their jobs with a spirit of dedication to international excellence. Scrupulous tidiness and order contribute to efficiency. To have won the good housekeeping pennant is a matter of pride to any section. Supervision of incoming materials is exacting. In the inspection area, rigid examination of materials and manufactured parts is the responsibility of highly qualified inspectors. Testing is aided by instruments such as this visual comparative machine. It throws an enlarged shadow of a part under examination onto the circular examining screen for accurate comparison with the original design specifications. Materials, such as paint, are made to international physical standards and laboratory checks in the works. This fracturing test is a check for film hardness and adhesion of succeeding coats to the metal surface. This is followed by a bend test for film elasticity and adhesion. And the viscosity of paint is determined by test also. All these detailed examination processes are part of the maintenance of high-quality standards in every phase of manufacture. Although engines are bench tested before being incorporated in a truck, dynamometer tests are also made to determine performance characteristics of international engines under all known operating conditions. All components of the engine are tested to ensure reliability, performance, and resistance to wear. Although the basic design of these international trucks originated in USA, Australian engineers have incorporated certain modifications to suit Australian operating conditions. And when the international test fleet takes the road, it is a cavalcade of trucks loaded to the capacities for which they are designed, proving on actual road tests that they have the stamina for which they are famous. And they have that stamina. Here is an example of it. A truck engaged on haulage from a quarry must be ruggedly built because the loading equipment works with vigor, not gentleness. The haul is steep in most situations like this. And to bring a full load up the quarry road gradient demands horsepower in plenty. Equally important is the need for reliability, for a truck off the road through breakdown loses money fast. International has a fine reputation for reliability. Public authorities like the State Electricity Commission put special emphasis on this same quality of reliability, as well as maneuverability and speed. When an electrical fault develops, dependability of transport is a must. These vehicles must traverse difficult country sometimes, where direction is a matter of the driver's instinct, timber is a hazard, and there are no roads to guide him. Such authorities must necessarily be very sure of their trucks. The selection of internationals for work which requires these qualities is an obvious tribute to their performance. Over all kinds of country, in all weathers, on the roads and through the bush, the International is a faithful ally of the Electricity Commission. On the access roads of the Snowy Mountains project, you'll see internationals at work the year round doing a sterling job. The Snowy workings are Australia's greatest engineering project. Internationals are to be seen on its steep mountain roads and in the snows, which each year add to the difficulty of the work which has to be done. Difficult work is a challenge which is readily accepted by International. For the whole essence of International design and construction is the manufacture of a truck which is a fine truck in every sense. The day of motor transport is here, and in the cavalcade of trucks which transport Australia's products, International takes pride of place, a fine product of Australian industry.